Hey, and welcome to the second episode of the Indie Game Journal. Today we're going to be talking about design and mechanics. Now you might have played games like Assassin's Creed and Call of Duty and realized that maybe in the last couple of years they have become, because these are series-based games and they have 200 plus people working on them at any given time, a lot of different systems have been embedded in them over time. So, for example, in Assassin's Creed Revelations they introduced a tower defense minigame, and this was met with mixed criticism because a lot of people would argue that that's not really what the game's about. Call of Duty introduced just this year a new mechanic where you have like a third-person camera and you get to control different squad members, and so it turns into sort of like an RTS dynamic. And again, people would question why it is that we would need that in a first-person shooter. Now, in independent games, this never really happens because when you have 2 or 3 people working on a game, it's not possible to create so many systems, and in fact, the games tend to be about just one system. Now, last episode I said that indie games were more indie in the game space because of their design and the way they are usually design-centric. What I mean by that is, because there's usually just one mechanic, or one core mechanic, the designer or the developer is very focused on creating content by giving the player one mechanic and then forcing that player to learn that mechanic and demonstrate that over the course of the game. And this is a very traditional concept, this very retro sort of arcadey way of making games. And basically what it does is it forces the design to be good, because otherwise you're not going to play it. If it's not fun for the first 5 minutes, it's not going to be fun 4 hours from now. That relationship between the developer and the user, that contract that I'm going to give you something fun and make it challenging for you for the next however long this game goes on, that's design, and that's basically good game design. So because I'm making a side-scroller, I wanted to talk about the different philosophies in side-scrolling games. Traditionally, of course, there are 2 big heavy-hitter platforming side-scroller games. This is obviously the Super Mario franchise and the Sonic the Hedgehog franchise. Super Mario Bros. Exemplifies what I like to call the static paradigm, I guess, where a designer has gone in and placed every single brick, and they have placed every single enemy because the system is so predictable every time. Mario jumps the same way every time, and if you're running at full speed, they can design these levels such that all you need to know is when to jump, and you have a perfect run, and everybody can match that perfect run because the game is so limited, and that's a good thing. And the design in that game would be to challenge the player to demonstrate their ability to memorize that system and use their reactions in a system like that under pressure. The other side of that is the Sonic the Hedgehog series, which if you look through the actual systems, Sonic has physics sort of embedded in it. It's not pure Vallee physics like Newtonian physics. It's like a hybrid sort of, it's almost like he's got gears. And that is a very different and kind of very modern way of designing a game for that time. Now the game I'm making is even, I guess, more modern still, and it's only really come up in the last, say, 5 to 10 years through the, I guess, proliferation of flash games and arcadey style platformers. As platformers have taken a bit of a back seat as a genre. You don't really see many Xbox games that are side-scrolling platformers, but the ones that are very arcade-centric. And basically, because of this arcadey nature of them, they have this design that's come up through just, I don't know, trends, is the infinite side-scroller. And the infinite side-scroller, converse to being a kind of design where you place tiles to generate the map, instead there's an algorithm. And the algorithm is just something like, a simple one would be a game like Tiny Wings, where there is a function, like a sine wave, and that basically is the ground. Now, the algorithm that Andreas Illiger would have used, if I pronounced that name correctly, in that game, would have been a basic sine wave but augmented with certain parameters, and the parameters define how difficult the game is. So the design in that sense, because the core mechanic is so simple, all you have to do is know that this level is harder than the last one. Not that this jump is harder, but that we know that because this parameter is in there, the space of possibility that this algorithm is going to pump out is going to be a little harder than this parameter. So it's an interesting sort of change in design. Instead of designing jumps and very specific low level elements of it, it's almost more top level. So, since this is the Indie Game Journal, it would be remiss if I didn't explain my process as well as the design, so how I implemented this. Basically, you have like a big infinite amount of space, right, that you want to try to get into your phone. And, you know, infinity doesn't fit into your phone because your phone has a finite amount of memory. So naturally, my first idea was to try to compartmentalize it down into something that I could quantify. Luckily, in Java, we have something that does just the trick for this. We have what's called an array or an array list, which basically is just a set of compartments that hold the same data type, but different actual variables of that data. So it starts at 0, goes all the way up to as much as your memory can hold, and basically that's what it is. An array list is expandable, an array is not. So I played around a little bit and I just thought, well, I'll use an array list big enough to fit what is essentially one level's worth of terrain, which I thought was, yeah, maybe let's say 5,000 units of terrain. And I threw them inside my phone and loaded them up into the game as a level. Unfortunately, because of the way games work, especially if you're using just one processing thread, what you're going to end up happening is the game stopping for 10 seconds, or essentially loading for 10 seconds just before the level starts. And we're kind of past that point now. Nobody has that much time. Not only is that not right, but it's not infinity. So I thought, let's try again. The next thing I tried to do was take that array list and basically generate screens worth of terrain that I would load every time I passed a certain threshold. This way I wasn't loading anything at the beginning that was so big, just every so often. The problem with that is, loading one of those screens worth takes time also, so instead of it taking 10 seconds at the beginning, you are essentially taking 10 seconds and dispersing that out as lag throughout the game experience, which is not good. Whether you want to put it at the beginning of your game and call it loading, or put it throughout the game and call it lag, waiting is something that no player wants to do. Now, as stupid as I thought I was at the time, and as impossible as this seemed, it actually wasn't too far off. Basically, in programming, if you have a big thing, like a big file, the only way to serve that, especially if they're not going to be seeing it all at once, is by breaking that up into very, very small pieces and giving it to them one piece at a time. And this is the same principle that the internet uses to serve you video content, streaming, instead of loading it at the beginning or doing it in chunks. Basically, it just gives it to you in small enough packets that you can watch it fast enough without actually having to wait at all. Effectively, what you're not watching doesn't have to be loaded yet. And the same can be said for video games. What you can't see on the screen doesn't have to be there in memory. You can load things as they appear on screen and unload them as they disappear off screen. As long as the player's experience isn't hampered by what you're doing, that's fine. And that's what optimization is. Optimization is stripping things down to what we only need for a good experience at any given time. To bring this back to our game, what you might like to picture the player as is, let's say, a short-sighted or a blind man on a treadmill. It's not like they can see what's ahead of them, so it doesn't really matter as long as they are having a good time at the time. So you might be thinking, yeah, that's great, but how do we fit an infinite amount of terrain into our phone in the first place? Even if we can stream it all, how do we fit it all in there? You might have heard me mention earlier a game called Tiny Wings, which uses what is called a sine function. Now, if you know your math, you know that sine is the trigonometric function that is equal to the ratio of the side opposite a given angle in a right angle triangle to the hypotenuse. We don't actually care about that at all. What we do care about is that sine basically takes a number and spits a number out. And luckily those numbers are between 1 and -1 all the time. So basically you just put any number in and you're going to get nice even hills that sort of roll on just like terrain. And you don't have to use just sine or just math. Luckily in Java we can use logic to build whatever we want and make that the terrain. So you can spend all day doing whatever you like, finding a function that makes sense to you, that you like, that represents your terrain. All you have to do then is just put in your in-game position, and what comes out is the appropriate height, for example in a 2D game, that corresponds to where you are on the map. So to answer your question, if you're trying to fit all this in memory, all you have to really do is just run an equation every so often to just find out where you are. It's not a matter of fitting infinity in so much as it is just knowing that whenever you want, you can run this equation and it'll give you an appropriate result. Now, coming back to optimization, it's a battle now between when you want and when you need to. The more processing power you have, the more frequently you can check, and the more high res your terrain will be. The only real questions you need to ask yourself at this point is how fast am I going to be going, how much terrain do I need to be able to see on screen at once to have a good experience, and how much processing power do I have to be able to keep adding to and removing from my array list. As for the length of that array list, the reality is, as long as you have enough ground for there to be something for you to stand on next frame, it can be as short as you want it to be. The graphics mean literally nothing. You can have whatever you want and it won't matter as per your actual running or your experience in playing the game. That said, you do want the visuals to match what's happening on screen. So that's essentially the path I've taken for my game, and it works really well. Running at a solid 60 frames per second at the moment on my GS2. Keep in mind that if you're developing for phones, there are hurdles you have to overcome in terms of compatibility. Some phones have more processing power and RAM, some phones have less. CPU is essentially how much stuff you can do per second, and RAM is how much stuff you can have on screen at once before the whole thing crashes. If you can manage to strike a nice balance between those two, then you are on the right track. So there you go, that's my little coverage on mechanics and design in indie games. Keep up next episode, because I'm going to be doing this. Seriously, look. You can click on it if you want. I would.